Hi, I'm Dr. Renato Yusulidum Jr., Undersecretary of the Department of Science and Technology and Officer in charge of the Philippine Institute of Volcanology and Seismology. In this session, we will learn how to gather baseline data, which are important for disaster rehab and recovery using the various GeoRisk Philippines platforms and data standards. At the end of the session, participants are expected to do the following: discuss the different GeoRisk Philippines platforms and data standards, and discuss how to collect baseline data using GeoMapper-PH and access available baseline data from the GeoRisk Philippines integrated system. Now, we will learn how to collect and analyze baseline data through GeoRisk Philippines. This figure shows the data flow from an agency to the database system, then to the data analysis platform, and back to the agencies. The logos indicate the agencies with information already in the database. Note that all information shared are for agency use only, unless otherwise specified for release to the public, or for sharing to other agencies. All hazards information from PHIVOLCS, PAG-ASA, and MGB are available to the public. Also, schools like DepEd and health facilities from DOH may be accessed by the public. We have placed DILG separately, as we think that local government units would benefit a lot when they contribute and access granular data through GeoMapper-PH. The platforms need information to process and analyze. This is the reason why we put premium on the information contributed to the system. To make data contribution sustainable, all GIS files submitted by the agencies underwent data cleansing, reprojection, and standardization. This will be the process for all succeeding data contributions. For the GeoRisk Philippines database, we developed thematic codes starting with numbers 1 to 8 to represent major data classification that may be needed for risk assessment. To your right are prescribed data that may be needed for rehabilitation plans. See how this information may still be put under specific categories in the thematic areas indicated. For example, hydromet and geologic hazards are under the thematic area named hazards, number 2 in our data standards. Infrastructure and housing might be categorized under exposure, number 3. Here is how this will look like. For the Philippines fault latest segment, with hashers facing to the west, as shown on the map, the 16-digit numeric code would be 2010-2001430100521. Note the colors corresponding to the numeric codes. Another example here, we see a green building, as pointed by the white arrow on the map. Its numeric code for now would be 3060-20105-000000. Based on this information in our system, the green polygon is a commercial building, particularly a bake shop that is made up of concrete hollow blocks. We can have more information by adding values to the 6 zeros contained in the 16-digit code. Given that we can now input information on a per building basis through the GeoMapper-PH, and that information can now be represented digitally by numeric codes, it is indeed possible to build the National Exposure Database. This database will be helpful for national development in that we could easily retrieve information on land use, critical facilities, natural resources, granularly from LGUs and NGAs. Let us see how we could use the GeoMapper-PH as a collector tool for our purpose. This is the National Exposure Database dashboard that shows us building footprints using GeoMapper-PH. The charts are monitoring tools that could help us identify certain features collected. We could also identify which LGUs need to fill out yet their exposure database and which LGUs are ahead compared to others. From this dashboard, we could also determine building construction materials used in particular locations. Adding more data fields, depending on the need of the agencies, is possible. All information may be accessed as spreadsheets or as GIS files as well. This slide shows a workflow for GeoMapper.ph. We start by preparing the data necessary for field survey. Here, we input building footprints, if available, and other base maps or high-resolution images necessary by the survey teams. Then, web and mobile applications are created, together with user roles for field surveyors. All GIS files are stored in specific databases which will be consumed in the web or mobile applications. New data collected, as well as data prepared prior to field surveys, may be accessed and visualized through local desktops and dashboards. Digitizing buildings is simple, as shown by the green polygon on the screen. Drop-down options are also available for easy input of information into the database. This is an example of building footprints as developed in a GeoMapper.ph for Cebu City. Polygons are color-coded to identify the construction materials used for the buildings. Administrative boundaries are also available to immediately visualize the location of the buildings. This is another dashboard developed for DTI that shows existing micro, small, and medium enterprises location in the Philippines. All data points have hazard assessments based on hazards information from PHIVOLCS, Pag-asa, and MGB. If you notice, there are point data. Please note that if you have existing data points, we could still use those for hazard and risk assessments. In the future, though, we encourage that you could fill the database system with polygons for more accurate assessments. Right now, if you do not have access yet to GeoMapper.ph, you could use and process publicly available information for hazards and risk assessments. The following slides will show you information available in Hazard Hunter.ph and in GeoAnalytics.ph. Again, this is the interfaces of Hazard Hunter.ph to your left and GeoAnalytics.ph to your right. Let us now dive into Hazard Hunter.ph. In Hazard Hunter.ph, you could select from different types of maps. Just click Base Maps. A list of options will be given you. Shown in the slide are Google satellite images and OpenStreetMap. There are also options from Esri Maps. Hazards information from PHIVOLCS, MGB, and Pag-asa are all available. Shown are the list of information that you can access. Exposure information from DepEd, DPWH, PSA, and DOH may be accessed as well. In the future, we envision that more agencies would contribute and constantly update their data in the database system so that the public and other government agencies may be able to use those information. Just recently, we added the safe open spaces in the National Capital Region. The information was assessed by PHIVOLCS as to safety from earthquake hazards and further processed by NAMRIA to come up with polygons and measurements of existing safe open spaces in Metro Manila to be used for earthquake evacuation. Advanced layers for engineers and planners may be accessed using the Advanced Layers feature in the app. What I showed you are salient information that you may access through Hazard Hunter.ph. The same information may also be accessed using GeoAnalytics.ph. Location information, demography, and institutions might be processed for summary assessments using GeoAnalytics.ph. Like Hazard Hunter, the same hazards information may be used for analysis. Here, we also see available exposure information. These are the major points to remember. GeoRisk Philippines is a multi-agency initiative led by DOST PHIVOLCS. It can be considered a governance platform as well as an ICT and geospatial platform. It has three main ICT and geospatial platforms: the GeoMapper.ph, the GeoAnalytics.ph, and Hazard Hunter.ph. Baseline data may be collected by GeoMapper.ph and accessed via the Hazard Hunter.ph and GeoAnalytics.ph. Thank you very much.